In this video, I'm going to explain how to solve systems of inequalities. For today, there are two important questions. One, what is a system of inequalities? What does that mean? And two, how can we solve it? First, I want to emphasize the difference between equations and inequalities. You might remember that an equation, a linear equation, if we graph it, looks like a line. And it means that any point x and y that satisfies that equation will appear on that line. The line is the set of all points that satisfy the equation. An inequality, on the other hand, is a little bit more flexible, a little bit more accepting. So if we've got this example, y is greater than mx plus b, it means that any point x and y that satisfies the inequality will show up in the solution. And that's going to look like a boundary line plus a shaded area. Half the plane will be shaded. So in this example, any point that's in the area above the boundary line satisfies the inequality, and any point that's below does not. So whereas the equation only accepts points on a line, the inequality accepts points in half the plane. So that's an important distinction to clarify before we go forward. So we've clarified the distinction between equations and inequalities. If you've already watched my video on systems of equations, you might remember that the solution of a system of equations is the point where the two equations intersect, where the two lines intersect. It's just one point, and that's the solution. It's the only point which satisfies both equations. But what would the solution of a system of inequalities look like? If each inequality is a boundary line with a shaded area, what does the solution of points that satisfy both inequalities look like? Well, it'll be where those two shaded areas overlap. So it won't be just one point, it'll be a whole area filled with many points. So let's look at this example. We've got a system of inequalities. Y is greater than or equal to 2x, and y is less than negative 1/3 x. So we can go ahead and graph these and see where they overlap. So for y is greater than or equal to 2x, we'll start at the y-intercept of 0, give a slope of 2, and connect those with a line. And we'll use a solid line because we've got a greater than or equal to symbol. And then because y is greater than, we're going to color above. And then for y is less than negative 1/3 x, we'll start at the y-intercept of 0, a slope of negative 1/3, and then we're going to use a dotted line here because we've got a less than symbol, not less than or equal to. And because y is less than, we're going to color below. So now you can see we've got a blue area and a pink area, and then where they overlap, or make purple as it were, is this area here in the bottom left. So it's got a dotted boundary and a solid boundary, and then a shaded area that satisfies both the blue and the pink inequalities. So any point that's in that area should satisfy both the blue and the pink inequality. And we can go ahead and test this by choosing a point that's in that area. So if we take negative 3, 0, and plug that into both inequalities, we can see that it does indeed satisfy both. So that area of overlap is our solution. In the next example, we've got y is greater than or equal to x plus 2, and y is less than or equal to x minus 4. So we can go ahead and graph these two lines, and for the first we'll color above, and for the second we'll color below. And then we're looking for the overlap for our solution, but you can see there isn't any overlap. We've got these two shaded areas, top and bottom, and they never cross. So for this system, there's no solution. We can't find any point that satisfies both. The last thing we'll talk about here is absolute value inequalities. For this video, I'm not going to go into great detail explaining how to graph absolute value functions. I'm going to assume you already know how to do that. If you haven't learned that, then this is a good time to pause the video and look for some resources on that and then come back. So for now, we've got this inequality. Y is less than or equal to 3 times the absolute value of x minus 1 minus 2. So that number at the end, outside of the absolute value, that negative 2, tells us where to move vertically for our vertex. So we'll go down 2. Then the number inside the absolute value, that negative 1, tells us how to move horizontally. And it's kind of the opposite of what you'd expect, so that negative 1 tells us to move our vertex 1 unit to the right. Remember that an absolute value graph is in the shape of a V, either facing up or facing down. And so that coefficient of 3, because it's positive, tells us that the V will be facing up. And it tells us that the slope of each of the legs will be 3 units up and 1 unit over. So we can sketch in some more points using that. And then we'll draw a solid line because we've got that less than or equal to symbol. And then because we have y is less than or equal to the expression, we're going to color in below the boundary line. And now we can test a point that appears to be in our solution area. So we'll test 0, -3, and we can replace x and y in our inequality with that and find out that, yes, indeed, that point actually satisfies our inequality. So it looks like our solution is correct. So now to wrap up, we'll think back to those 2 questions from the beginning of the video. What is a system of inequalities? And how can we solve a system of inequalities? So I hope that now, after watching this video, you have a better sense of how to answer those 2 questions and you understand them. If not, feel free to reach out to me with your questions and I'll be happy to go into more detail. That's all for now. Thanks for watching and have a great day.